Welcome to the Software Process and Measurement Cast number 732. I'm Tom Cagley, your host. Today, we feature our interview with Robert Cooke. Robert and I discuss the role of software development in delivering value in non-software product organizations. Robert Cooke is the founder and principal architect of 3Forge, a New York-based provider of data virtualization and visualization technology. 3Forge has achieved significant growth over the years as a result of increasing demand for its award-winning web-based browser AMI platform. Today, AMI is deployed at 3 of the 5 largest global banks, and nearly 20% of the global equities flow through the platform. 3Forge has provided its service to hedge funds, broker-dealers, and other financial service firms. The company is a leading provider of performance at scale data management systems. Are you ready to talk data virtualization and visualization? It's time for the interview. Robert Cooke, why don't we start at the beginning? What's the role of software development in delivering value in non-software product organizations?
Just to think that there's over 100 different ways of, storing a piece of data on disk in that really ultimately they're very, very similar from one instance to the next is pretty startling. And I could go through, everyone knows the common databases like MySQL and Postgres and SQL Server and Sybase. But then you get into other things, RocksDB, and I can go down the list of very sort of esoteric databases that maybe people aren't familiar with. And, so there's a lot of work that has to be done just to try to normalize all the different ways. I actually think one of the simplest examples you could make up would be, and this is very trivial, but I think it at least sets the stage, is all of the annoyance we have to deal with to get really down technical to it. It's like Windows, you're using backslash. On Unix, you're using / on Windows, you got /n/r, and on Linux, you know what I mean? So just like little differences like that create all these annoyances that we have to work around.
When I ask whether or not software development's a real thing, in a lot of organizations, people, whether they classify themselves as engineers or software craftsmen or whatever word they use or whatever phrase they use, are there to actually just cobble other things together versus creating or solving a new problem. Because I think you're right. A lot of what we need has been done before. And if you're really smart, you figure out, well, I'm not going to have to rewrite that again and again and again because that's expensive.
Mm-hmm. Well, I'll tell you, I had, there's an influential individual I worked with at one of the tier 1 banks. He actually went on to start another corporation, another software firm. But I'll never forget when I was, wide-eyed 20 years ago, and I said, there's all these new things in technology, and there's all these new ways of doing this and that, and look at all the stuff that's coming out. The guy just turned to me and said, there is nothing new in computing in the last 20 years. Pretty much everything that computers can do, they could do in 1980. And I really, and he said, prove me wrong. And I really thought about that. It was anything I come up, inversion of control. And he could give me an example or a white paper that was written about that 20 years ago. What about this? What about that? And so, definitely, I think, a lot of the fundamentals of computer science were really established in the 70s and 80s. And from there, it's just been kind of spinning wheels and trying to figure out how to grow this out. And I think one of the, as you said, when you actually start to dissect the software industry, of a large portion of it is, yes, just people cobbling things together. Now, with that said, I've also cautioned the business or the ones running the budgets, paying attention to the P&L of these firms. 20 years ago, pretty much anything you threw a computer at, you could cut costs with, because everything's being done manually. I mean, I literally, when I started in 2000, one of my jobs was to take the physical clocks that you would put a card and punch it into and it would stamp the time, and to make that into a piece of software. And it saved a lot of money because you didn't have the physical clocks anymore. I mean, but I use that as an example to say that, in the beginning, pretty much making anything electronic, you could save money and make things more efficient. And so I think there was this real sort of this attitude of just get it done, just make it work. the academic interest of trying to do it in a more efficient way or a more streamlined way. Who cares? Just get it done and let's save some money. And in the beginning, almost all of the budget is on these sort of mechanical things and very little spent on electronic or I would say software technology. And then over time, you start to see the software budgets growing and growing. My background and most of my customers are in fintech. Asking around, it's hard to get a solid number, but we're crossing the 50% point where more money is now spent on the development of software than on anything else. And so this concept of who cares about the efficiency and the elegance in which we solve a problem, let's just get it done and save money. Those days are now behind us. And I believe because if we keep following that, eventually your costs will be 100%, right? And the way you're now going to compete is by spending less money, by being more efficient, being able to do more with having to maintain less software. And I think one term I really like is something that's thrown around a lot, at least in our industry, is technical debt. Which, the idea is back in the day, it's like you're writing all this code and you feel like it's something you're adding to the balance sheet. While in fact, it's not adding to the balance sheet, it's subtracting from the balance sheet. You basically have tons of technical debt that you're trying to move away from. And again, I didn't come on here to complain. And in fact, I think it's really exciting. And I think, we definitely have made the world a far more efficient place. I mean, people take a lot of things for granted that didn't even exist just a decade ago. But at the same time, to push it to the next level, we have to really step back as an industry and say, how can we start doing things in a more intelligent and more efficient way?
So, I mean, and I didn't take any of that actually as complaint. I look at that as a significant opportunity. If an organization is spending half of their budget on software, I have to guess that a substantial portion of that is logistics and actually maintenance and other kinds of things that one would rather try to avoid it if at all possible. And so that leaves us with opportunities to, whether it's creating new functionality or putting things together to do that in a manner that is less risky or has less debt. Does the whole idea of the Internet of Things and the things emergent, it's getting less emergent every day, things like AI, change your perspective on how this goes?
Yeah, sorry about that. So I would break that. I'm going to break that into two questions there.
Excellent.
In terms of the IoT space, I think it's funny actually. When I think back, when I was much younger in grade school, I did a presentation about how I thought at some point all of your house would be connected and everything would be able to talk to each other and you'd have a much smarter home. So I have to say, I've always kind of had this feeling that the IoT was going to come, eventually to fruition. It actually took a lot longer than I thought. It's interesting because now with IoT, we get to deal with even way more data than we had to before. Now with all of the data being produced and all the information out there, there's definitely a lot of opportunity to grow and get value out of it. But I would say that we need to go into it with a little bit of caution because I look at it as that first piece of information that you get is very valuable. And as you start to get additional information, the value drops as you start to get more and more information. The value per piece of information. IoT is now flooding us with data, is now flooding these systems with data. And there's so much you can look at. So now it's becoming more of how do you really find that needle in the haystack? And then that opens up the second part of the question, which is around AI, machine learning, which I do try to differentiate those. I do look at those as pretty different. I'm not really that involved in AI. I will concede that. I'd love to do that when I retire and play around with that stuff. But I've done a lot around with machine learning. And I also think that there's a lot to be said for data analysts or people that are, and I use that term broadly, data analysts, I should be more exact, people that are really good at searching through data and finding that proverbial needle in the haystack, which I think is an interesting and valuable skill. So machine learning along with, and it's almost when you really get to the top of your game, I think people that are good at finding data actually have some understanding around machine learning as well and able to create these models to look for that. So I think it does open up a new opportunity to make money, to, learn new things and add to the balance sheet. I think IoT is definitely in that space, yes.
It sounds like IoT could also push past the point where there's any marginal return on data. I mean, it could overwhelm organizations.
Yeah.
Is that where platforms come into the picture of actually putting them all together?
Okay, so this is how we focused our platform on this problem. We've broken. So what the platform is focused on, what 3Forge is focused on, what I've spent my life thinking about is how do humans interact with data. And I've actually broken it down into 3 different categories. So the first category is what I call real-time streaming, which is which IoT definitely plays into as well. Which the idea is that as data is taking place live, there's systems that can analyze that data, look at that data, find anomalies, and basically raise awareness to operators in real time. So that's the first thing. The second thing is the ability to ask questions about data, to basically be able to, from your computer or from some device, be able to ask a question, have the software go back, run analysis on the data, and give you an answer back. And then the third thing is to be able to do data entry and workflows. So I can give a very quick example of each of these, just using email and Google. So real-time streaming, you could say that's like you receiving an email, right? You're just sitting there and all of a sudden an email shows up. That's kind of an idea of real-time streaming. The second thing is you do a search on Google. That would be asking a computer a question and getting an answer back. And then the third thing would be data entry. That would be like the equivalent of writing an email. Now, I use that as a trivial example. Generally, what I'm talking about is you have millions, or in the case of market data, maybe tens of millions of events coming in per minute that you need to analyze. You find something interesting, and then you want to be able to go back and research that. When you find some interesting research, now you want to be able to interact with your colleagues. So we focus on this concept called leave the data where it is, which really says, let's say you've got a distributed IoT infrastructure. What should be happening, in my opinion, is the different IoT devices should have some awareness of what's interesting and what's not. So, for example, let's say you've got a thermostat. The thermostat ideally should not be reporting back the temperature to the mothership every 30 seconds. That's not an ideal way to do it. Instead, what it should be doing is reporting back with the delta, saying in the last 5 minutes, we saw the temperature go up and then down, or do something like that. Basically produce a profile change over time. And so that reduces the amount of data you're moving around. So instead of always moving these absolutes, instead you're kind of telling a continuous story. Now, let's say we are at the mothership and we all of a sudden see that 20 thermostats have all simultaneously said the temperature has gone up 5%. And again, I'm just making an example here. At that point, the mothership may want to be able to go back to those devices and say, what now, give me that detailed information. I want to know exactly what happened during those 5 minutes. And the device comes back and says, this is what happened. And I think this becomes an important thing, because as the data gets larger and larger and larger, and it's only going in that direction, you have to be able to focus on what is interesting and then be able to then go ask questions about that data later. The idea that everything gets pushed into one, big mainframe, like on that Superman movie, it's just not going to happen. There's no concept of being able to get it all into one spot. At least I don't believe that's going to happen. So you really want to get the interesting information in one spot, then be able to ask questions of that, and then have that relay back to the infrastructure where you can get those answers back.
Doesn't that put a lot of intelligence at the edge versus trying to bring the intelligence, into some sort of centralized, whether it's, the Superman mainframe. By the way, I actually saw a mainframe the other day. I didn't know they still existed.
They do. We integrate with some of them.
There you go. I mean, doesn't that fly in the face of a lot of dumb, dumb is probably a bad,
No, it's a great term. Yeah, dumb terminals, dumb Hardware. Yeah, sure. I know exactly what you mean. Maybe my example was a bit too literal.
Mm-hmm.
I would say so. Maybe in this case, you would have the thermostats, and again, I'm just going on this analogy here. You've got the thermostats in the house. You might have a computer in the house, so the thermostats are reporting detailed information to the house's mothership. That is only reporting the interesting information up. So my point is, if you can envision kind of an upside down tree where you've got lots of tentacles and they're all gathering information, almost literally how an octopus works. I mean, they actually have little brains in their tentacles, believe it or not. Like that's how they're constructed. So the whole idea is that, as the information comes up, it's getting gathered and stored, analyzed, and pushed up. If you try to take everything from every single tentacle and push it all up to the top, it's going to overwhelm the system. It will eventually. And I'm at least in the industry, and by the way, I will say, I also have this concept that I think fintech is the canary in the coal mine. I mean, people in finance have been using computers longer than just about any other industry, except for maybe the military. And we have been designing and building systems that are designed to electronically fight each other, literally creating data at the speed that computers can. So I very well know what it looks like to have hundreds of computers each receiving millions of events a second. And there's no way to capture that and push that all up into one system. You have to be willing to say the individual systems store the data and they basically process the data they're interested, push up what is interesting to the next level. And then when you need to go and do that analysis, you then work your way back down, ask the questions, and get the underlying data when you find something interesting.
So is that where people come into play in terms of whether it's constructing those mathematical algorithms to trigger or at least identify what's interesting at those different levels? Is that where people come into at least the construction part of this?
That's exactly right. I mean, that's where a lot of the software patents are coming out these days, is in that part. That is the interesting piece of it, which is, yes, looking at these real-time streams of data and then being able to analyze and find what's happening. Things like windowing, et cetera, et cetera.
Is this cutting edge today?
I think so. Yeah, absolutely. I mean, I think I consider myself very fortunate. I worked on the high frequency trading group at Bear Stearns in 2004. When high frequency trading was still pretty new. Back then, we were dealing with events in milliseconds. We thought that was fast. Now we're, the systems I'm integrating with are now pushing past the microsecond into the nanosecond. And the analogy I love to use is light only goes 1 foot per nanosecond. So we're talking about transactions that take place in, 100 light feet. I mean, it really is just astounding at how fast things are taking place. I look at this as very, very cutting edge sort of stuff. And I think, and again, I come back to, I don't know if I mentioned at the beginning of the call, but what I've always loved about computers is it's just us against ourselves. We can always be smarter and we can always be more efficient about it. It's just how, you can always take an algorithm. I feel like, at least in my life, I can always look at a piece of software and you can make it faster and you can make it more efficient. And it's just being able to really focus on the right problems and not be constantly focusing and trying to solve the same wrong problems over and over again, which, again, not trying to complain, but I think a lot of time is spent on frankly trying to solve the same problem over and over again.
How do platforms like ThreeForge actually enable the delivery of value, and how do they? You've talked a little bit about the sort of the philosophy. How do they enable value?
Right. So the thing is, well, first off, one of the key things that triggered me to start this and convince a lot of colleagues to go along this path with me was, everywhere I went, all the different banks I was going to, consulting full-time as managers, project PMs, managing the budgets, etc., it was the same problems being solved over and over again. And whether you're a crossing engine at a dark pool or you're building a high-frequency algo trading engine at a tier 1 bank, or you're focusing on some of the strat arb model at a buy-side firm, 90% of the problem is the same, and 10% of it is truly the intellectual property that sets that organization apart. And to me, I felt there was a huge opportunity to save companies a lot of money, let them focus and let them get products out the door much faster. If I could say, look, we'll solve the 90% boring part that really isn't your intellectual property anyways, and then you can focus on that 10% intellectual part. And so I go back to the simple mundane exercise of connecting to lots of different databases. So a simple example of something we can do very well is if you've got, let's say, market data sitting in one type of database, like a columnar database over here. You've got, let's say, reference data, like information about companies sitting in a Mongo database over here, some non-structured database, and then you've got your trading information sitting in a third database. We can query all of those simultaneously, bring that together, normalize it, and then let you work with that. That's a good example of something that we do. Another thing that I think way too much time is spent developing over and over again is the internal dashboards for, again, those three problems I talked about: being able to ask questions to your computer, being able to see things that are changing in real time, and being able to do data entry on a kind of a customized basis. So again, if I go back to any one of these examples of where I worked in the past, there would always be, okay, we see a trend in the industry, something new is coming around. We need to build the next whiz-bang software to solve that. And that would always have a few things. One, it would have the actual intellectual property, which would be the business model that would make the decisions about the data and things along those lines. Then there would be the transactional component, which is how do you get information from point A to point B. There would be the persistence and storage component. And then there would be the visualization component, like how do people actually see the data and work with that data. And of those four categories I talked about, three of them don't actually really get the firm any additional value to their bottom line. They're just building it over and over and over again, right? And that's why I felt like if I just could, and so what I did was I went and I talked to everyone I knew in the industry, and I said, look, explain to me about the problems you're solving and how you're solving them, the sort of technologies you're using. And then I just did that as many times as I could. And then I sat back and said, okay, now how can we build a broad framework that's just going to solve all of that boilerplate stuff in a generic way?
How has that changed their behavior? You've solved that 90% problem for them. How has that changed their behavior?
For me, I love it because, again, as soon as you solve one problem, it just opens up the next problem. So we have, I would say it's changed behavior in a few ways. One, it's allowed them to reduce and refocus developer teams on the intellectual property. I think for our customers, I think one thing I'm particularly very, very proud that we've been able to help them do is a lot of times, and I shouldn't say a lot of times, in almost all industries, people tend to design the way the industry functions based on sort of a siloed approach. So I'll pick fintech because that's what I'm used to. So there's asset classes, you have equities, you have fixed income, you have foreign exchange, et cetera. And for each one of those, there would be a team of developers, and they would get to understand that particular asset class very well, and they'd solve that problem very well. Now, the problem is, now you're a customer of this bank, and you start to trade and use those products. If you actually called up and said, hey, you know what? I happen to have a commercial account with you, plus plus I'm also trading equities, and I'm also trading fixed income, and I'm using you guys for foreign exchange. Can you tell me my position? Can you just tell me what's going on? They're going to say, you got to talk to four different groups because
let me transfer you.
Exactly. Let me transfer you and transfer you and transfer you. And I think it makes sense. I mean, that's how humans solve problems. We bucket them, and then we go and we solve them, and we can do that in parallel, and we can create teams and managers and do that. But the problem is then the customer comes in, and they don't really care that the problem was solved that way. They want to come in and just see their world. They want to see things according to their mental model, not how the company was built. And so using, basically having technology that can cut across all these different industry or all these different product groups basically gives the customer a much closer to mapping to what they expect, to what their mental model is.
Robert, you woke up tomorrow morning, somebody handed you your cup of coffee or your tea or whatever your caffeinated beverage of choice was, and a magic wand, and said that you had the power to solve any two problems that affect software development. What would those two problems be and why?
Oof, I have to pick just two.
Just two.
Just two. I think, boy, yeah, if I had to solve two problems, I think one of them is that we're stuck in a rut where, and this is going to be a very long answer, but I'm building up to the answer to the first one, which is when I look at the history of computing, which I'm actually very fascinated by how we got to where we are. And just to give very broad strokes, it's like, we started off with hardware solutions where literally every time you wanted to change the program, you'd build new hardware. And then someone realized, well, we can actually, have logic gates and software, so we don't need to rebuild the hardware every time we want to solve this problem. But then at some point we said, well, you know what, the time, and if you make mistakes reprogramming it, that's an issue. We need to have compilers. And then at some point they said, you know what, having compilers is great, but really we need to have an operating system because it doesn't make sense for people to, directly integrating with interrupts and things like that. And then at some point someone said, why are we writing software that's physically reading and writing from the disk? We need databases, a way to store data and read data back. And then it seems almost as if it stopped at that point. We've got operating systems, we've got databases, we've got file systems and these other sort of logical components. But I do believe the way we push software to the next level is people need to be optimistic and start to think that there is a next level that we can go to, where when I envision how the world should be by now is that there should be almost a next level operating system, like a smart desktop that basically says you build your business components quickly. You're not worrying about the nuances of, how does this piece glue to that piece? And instead you're using these high level platforms to basically build these solutions. I think that's one thing. I think that we're spending way too much time still thinking about procedural languages when I think there's much higher level sort of concepts we can be working on. The second thing is, I would say I would change is, I feel that now it's going to almost be the opposite answer, which is I believe in academia that there's way too much focus on trying to get students the high-paying job straight out of school. And, it's like, it's almost, and what's interesting is I've gotten older, I've realized that whatever academia teaches seems to become the standard 10 years ago. Like everyone was taught apps, and all of a sudden everyone's building apps, and you kind of ask yourself, well, why is Python so huge? I mean, Python's an okay language, but it's because it was taught a lot in the schools. And so I think that there needs to be a lot more focus on how does a computer work, how do data structures operate, why is math an important part of computing? Because if you don't understand, I'm not saying you need to understand like how to, do integrations and things like that, although it helps. But, at least having a good understanding of how a data model or a data structure is going to operate and being able to work that out with pencil and paper, I think is an important thing. And so I guess that's the other thing I would change is I would say, and I'm not saying that it needs to be decades long of learning this stuff, but I think there just needs to be more of a starting from the basics and then working their way up as opposed to the other way around.
Yeah, it's become much more sort of like going to an old tech school and learning how to do something versus thinking through how to actually think through solving the problem. Yeah. So no, math would be a good thing. And obviously, if you end up in the data science world and you don't have the math, you're not ending up there.
I wish that were true.
Oh, no, that hurts. Oh my God.
It is. But no, I mean, you're absolutely right. It is frustrating when, data scientists should be good at math and they should be good at statistical analysis. That is, it's an important thing.
Absolutely.
Yeah.
Robert, this has been fantastic. How would people continue the conversation? How would they find out about you, Three Forge? And then we'll do a little bit of a promo at the end.
Okay, sure. So 3forge.com, that's our website, 3forge.com. And we put out a lot of information on our social media LinkedIn account. So 3Forge business account on LinkedIn, basically every few days, at least once a week, we post something new about different technology we're interacting with or things we've added to the product. I know I've mentioned it a few times, but one of the things about 3Forge is we have experienced and integrated with just about every real-time streaming system and every type of database there is. And I say that, and then it seems like there's another database next week I haven't heard of.
That's why this is a dynamic business, right?
Exactly. So, but at the end of the day, we have a lot of industry knowledge, a lot of subject matter expertise in terms of what the different databases are good at and what they're not good at. We post a lot of that online. We talk about that sort of stuff. That we think that's very interesting how that stuff's evolving. So, anyways, 3Forge on LinkedIn.
Cool. I will have that contact information in the show notes. At this point, I open up the platform for you to promote anything that you'd like. And other than perhaps selling your car on eBay, the podcast's been around for a long time. You really don't want 16 years from now getting a call. Do you still have that? Yeah. Of course, by then it'll be flying cars, right? Someday.
Mm-hmm. Yeah. Well, maybe used cars will keep going up in value. Who knows?
Who knows?
Sure. Well, I'm definitely happy to promote the company. I like doing these podcasts to kind of have philosophical conversations around technology and this and that. And I hope that I've been able to persuade people that we really are thinking very hard about how to build a product in the long run. And by that, I mean, in 2012, so a lot of people would look at our software and say, it looks like it's a visualization. In fact, if you went to our website, we talk a lot about the visualizations and how to see data and interact with data, but it's kind of that iceberg thing. When we started the company in 2012 out of New York, basically 2012, 13, and 14, we didn't really focus on the front end at all. It was all around how do you do scalability and processing of data. And then 2015 and 16 and 17, we could start to focus on the front end. And then actually 18, 19, 20, now we've evolved into how do we start building tools to allow developers to more rapidly build dashboards and analyze and find issues and things like that. So the product has evolved a lot. We opened up a support office in London 2020. We opened a support office in Singapore in 2021. And really that's because our customers generally have 24/6 or 24/7 business. Follow the sun, where you can call into their desk anytime around the clock and get support. And so they also expect to be able to call us up and get support if they have questions about the software, this or that. So we're very involved in, we look at ourselves as high touch when it comes to making sure our customers get what they need. And then we also focus a lot on the platform. And in fact, we look at our customer base as a consortium. And so by that, I mean, every quarter, we ask our customers, what are they looking for us to add to the product? They tell us, we try to get it into the following quarter so that we're constantly meeting the demand of, how the industry is moving. And that's actually very interesting as well, being able to see the pulse. And by the way, we have 5 top tier 1 banks. So these are like household names that, my grandmother would be familiar. So, we're listening and we're interacting with those firms a lot to understand where they see the trends going. So it's been a lot of fun. Yeah.
Sounds like a lot of fun. Robert Cooke, thank you for sharing your expertise and, helping people think about how the world of development is changing and evolving into the next 10, 15 years.
Yep. Onwards and upwards.
I hope so.
In Reread Saturday News, this week we reread Chapter 4 of Extraordinary Badass Agile Coaching. By the way, saying badass never gets old. Chapter 4, Badass Agile Coaching Agreements, focuses on the need for and structure of coaching agreements, hence the name of the chapter. I use coaching agreements on a regular basis. They're an excellent idea. Bob Galen states, my point being, never, ever coach without establishing an agreement. So, like process improvement, why do so many people not do this? Links in the show notes to this week's installment of Reread Saturday. In the next Software Process and Measurement Cast number 733, we'll continue our answer to the question, if one product owner is good, aren't 2, 3, or 4 better? We'll also have a visit from Jeremy Barrio, brings his wide-ranging QA corner to the podcast. If process improvement is a never-ending journey, why do so many people ask, are we there yet?